Hello, my name is Ryan. Welcome to my project. I am a master's student at Kennesaw State University, and I am completing this project for my Introduction to Cryptography and Apps class. I have chosen to do my semester project on how blockchain technology works and how cryptocurrencies, specifically Bitcoin, are able to utilize this technology. In this presentation, I will go into depth on how exactly blockchain technology works, how it is being used today, and I will cover some future applications that blockchain technology could be used for to help improve security in other sectors. So, what is blockchain? This takes us to the question of what blockchain really is. Basically explained on a low level, blockchain is a decentralized ledger system that contains records or blocks, hence the name blockchain, that are securely joined, that's where the chain part comes from, using cryptographic hashes. Blockchain technology uses a peer-to-peer computer network setup to make it decentralized. So, where did blockchain come from? The idea of a blockchain-like protocol was first suggested by the cryptographer David Chaum in 1982. He wrote and titled his dissertation Computer Systems Established, Maintained, and Trusted by Mutually Suspicious Groups. And he talked about a decentralized system such as blockchain in this dissertation. It wasn't until 1991 where Stuart Haber and Scott Stornetta began work on what they would describe as a cryptographically secured chain of blocks, in which timestamps could not be modified. In 1992, they utilized Merkle trees into their design of these chains of blocks that were cryptographically secured. This was the basis for the structure of blockchain technology. In 2008, the computer engineer Satoshi Nakamoto came up with the first truly decentralized blockchain used by others. By 2014, the size of the ledger was about 20 gigabytes, and by 2020, the size of that same ledger had grown to about 200 gigabytes. He is the person that applied blockchain technology to Bitcoin, and which is what made Bitcoin grow so much. So, how does blockchain work? On a very basic level, blockchain takes blocks of data that are linked together in an unmodifiable chain and allows the ledger of these blocks and transactions to be decentralized. This means that any machine on the blockchain network at any given time has its own copy of the ledger. Each block in the chain contains the data itself, the hash of the previous block, and the new hash. For a Bitcoin application, the data would contain the wallet ID of the sender, the wallet ID of the recipient, and the amount of Bitcoin being transferred. The hash of the current block is unique, like a fingerprint, and changes based on the data, which allows easy detection of changes to the block. Each block in the chain can be traced back to the previous block through the hash value, which is what makes it so secure. If someone tries to modify the data on any given block, this causes the hash value of the block to change and will invalidate any block after it, as the hashes of all subsequent blocks will not match. One way blockchain keeps this secure is called proof of work. In theory, with the speed of modern computers, an attacker could modify the data on a single block and calculate new hashes for every block after that in the chain. But proof of work forces each new block creation to take 10 minutes to calculate the hash value. Now, if an attacker wants to modify a block, you're talking about them have to having to not only recalculate hash values for every block down the chain, but now it's going to take 10 minutes per block to calculate these hash values, which on a system the size of Bitcoin is almost impossible to do. Fun fact, the first block in a blockchain is called the Genesis block. The last security measure that blockchain technology implements is the fact that it is decentralized. Every user on the network has a copy of the chain and ledger, and when a new block is added, it is sent to all users for verification. If the hashes don't match up, the block is rejected. For a block to be accepted, there must be a consensus that the block is not fraud. Only then can a block be added to everyone else's ledger. What makes blockchain technology so secure is the fact that for someone to commit fraud, they would have to control or have a machine more powerful than 50% of all users in the whole system to be able to get a block to pass, which is near impossible. Now we can talk about other applications where blockchain is being used today. Outside of the mainstream application of blockchain technology in the cryptocurrency Bitcoin, blockchain technology today has uses with smart contracts, financial services, and supply chain management. This technology allows extremely secure record keeping and contracts in all of these applications. There are also many future applications where blockchain technology could be used, but is not being used at the moment. But with these topics, people are currently working to apply blockchain technology to these sectors. These sectors include IoT or Internet of Things devices and smart contracts. Blockchain technology offers security unparalleled to what is available at the moment in these sectors because it is decentralized and because of the cryptographic hash technology used to seal each block. So, why did I choose this topic? I chose the topic of blockchain technology and how it works with Bitcoin because I feel that blockchain technology is very prevalent in today's society, and it is a word that many people throw around and use when talking about cybersecurity, but they don't fully understand how it actually works. When Bitcoin became really popular in the mid 2000s, everyone was crazy talking about Bitcoin and blockchain, and those were the hot words, but I feel like it would make me more valuable in my career to not only understand how exactly it is blockchain works, but how it could be applied in the future to other sectors. Should you or anyone else care? Well, blockchain, as it is still very new, is something that has proven itself security-wise within Bitcoin specifically, but within many other cryptocurrencies that use it. It is a very secure way of storing data and monitoring transactions. You should also care because there are many future uses for it as discussed. Many people use smart contracts to sign things for people who do business internationally who rely on these smart contracts, and they can be spoofed. And blockchain technology with a use in them is a much more secure way for someone to sign contracts to use in business. There are also many other uses for blockchain technology, such as Internet of Things devices, which are very inherently insecure and create many vulnerabilities for many networks. So, cryptocurrency through the blockchain ledger created basically a digital cash. It is anonymous, non-traceable, instant, and decentralized. Cryptocurrencies using this blockchain technology allowed us to transfer value without a centralized authority like a bank or the government. This is why a lot of experts would consider blockchain to be a solution to a problem known as the Byzantine generals problem. This Byzantine generals problem refers to a war on the Byzantine Empire when two different groups wanted to attack, and the only way for them to communicate and attack at the same time was to send their messages through the city. But the issue was the message could not get caught in the city or be intercepted and replaced by fake news who would basically give fake news. Blockchain technology basically takes this middleman out and gets rid of that issue because it operates on a peer-to-peer network. So for someone, like I stated in the previous slide, for someone to mess with the data or an attacker to do something nefarious, they would have to have a computer more powerful than 50% of all machines on the network, which is near impossible in today's standards. Now, one of the downsides that people don't talk about is maintaining Bitcoin specifically, or any large network using blockchain technology, takes a lot of work. There's a lot of machines that have to be on this network that mine the Bitcoin, which essentially these computers or people are paying to have their computers on this network to calculate the next cryptographic hash. And as a reward, on Bitcoin specifically, they are rewarded Bitcoin money. Now, a lot of people don't take into account that the machines that are used on the network and carry out these processes consume a lot of electricity. So it's not a perfect system, but from a security standpoint, it is very secure and near perfect. Part of the reason I also decided that I wanted to do this project on blockchain technology is that I personally feel that blockchain technology is the future of security. Think of working for a large company that stores a lot of data and has email that uses blockchain technology. If they get hit with a ransomware attack, theoretically everyone has a copy of this ledger, and an attacker can't just attack one server and encrypt all the data and demand a ransom because the information is stored in so many places. They would basically have to control every single computer on the whole network. Now, this is easier to control and attack a company which may have 100 to 500 computers, as opposed to something as large as the Bitcoin network, which has millions of machines on there, which is, like we discussed, near impossible to attack. But I do believe it is the future. Another point I discussed was Internet of Things devices. They are very inherently insecure and not designed from a security point of view, because a lot of these sensors and devices are such simple devices that security was just an afterthought. Using something like blockchain to monitor and allow these devices to authenticate into a network would essentially use some kind of cryptographic hash where each device's hash would have to match the last one. So if an attacker wanted to attack a system and go through an IoT device, they would basically have to be able to change the cryptographic hashes on maybe hundreds, maybe thousands of these devices on the network or around the world, or whoever's using them. To close, these are the references that I used to complete this project. They include web articles, dissertations, and videos. I believe that these resources help me to fully understand blockchain technology and to complete this project successfully. In the next slide, I will insert my references that I used for pictures in this presentation. these are the links to the sources of where I use the images for this presentation.